Number 2 Honors, Lesson 5.2, Properties of Parabolas. Here are the lesson's objectives. Okay, so let's talk about quadratics. The first thing we'll learn about a quadratic is standard form of a quadratic. Right, the standard form of a quadratic is ax squared plus bx plus c. Okay, an example with numbers would be 3x squared minus 5x plus 1. Right, in this example here, 3 would be A, negative 5 would be B, and positive 1 would be C. Okay. Now when you graph a quadratic, alright, there's two different shapes that you might get. The first one is a U, or what I call a happy face. The second one might be an upside down U, right, what I call a sad face. Okay, so when is the parabola going to be happy? Okay, when is the quadratic? When you graph a quadratic, this U shape is called a parabola. Right, so this parabola will be happy when A is positive. Okay, when A is negative, right, the parabola is going to be sad. So that's a kind of an easy way to remember, right, when the parabola is happy and sad. If A is positive, positive means you're happy. You're right. If A is negative, if you're negative, then you're sad. Okay, so that's when the parabola is happy, right, and when it's sad. Okay. Now in this graph right here, this parabola is happy. Okay, so if it's happy, this lowest point right here, right, there's a name for it that's called the vertex. Right. In this case, the vertex is 1 and negative 1. All right, and then we can also have a line. All right, there's a line that goes straight down the vertex vertically, and this line right here, right, that splits the parabola in half. A parabola is symmetrical, right? It's symmetrical, meaning its distance, for example, from this point, right, to the axis of symmetry. That's what this line is called. Is equal, right? That's what symmetrical means. Okay. Now, so this line right here is called the axis of symmetry. Okay, the axis of symmetry. Okay, it splits the parabola in half, right, making both sides even, right, symmetrical. Okay, now to find the vertex of a parabola in standard form, right? So if you're trying to find the vertex of a quadratic, right, or parabola in standard form, all right, to find the vertex is a coordinate. Okay, to find the x value of the vertex, right, you use negative b over 2a. All right, to find the y value of the vertex, right, once you find x, what you're going to do is you're going to plug x, all right, into the problem and work it out, and whatever your solution is once you've worked it out, all right, after you simplified the problem, that'll be the y value. Okay, and it'll make more sense once we do an example. But just remember, if the quadratic is in standard form and you need to find the vertex, first you will find x using negative b over 2a, and then once you find out what x is, right, you're going to take that and plug it into the problem to find out y. Okay? Alright, so let's take a look at, right, this first example here. Okay, so we've got a function, alright, y is equal to x squared minus 2x minus 3. Alright, so this is a quadratic function. Right, now we need to find the vertex and the axis of symmetry. So first let's find the vertex. In order to find the vertex, what we need to do is, right, the vertex is a coordinate, so we need to find the x value of the vertex. In order to do that, we're going to use negative b over 2a to find x. Okay, so to find the x value of the vertex, right, it's equal to negative b over 2a. So that's going to give us our negative, because that's in the equation, and the b value in this case is negative 2 over 2 times a. The a value is 1, so it doesn't give us positive 2 over 2, which results in 1. Alright, so the x value of the vertex is 1. Alright, to find the y value of the vertex, what we're going to do is, alright, this was our problem. Y is equal to this, so we're going to take x, which is positive 1, and plug it in for x. So we're going to have 1 squared minus 2 times 1 minus 3. So 1 squared gives us positive 1. Alright, negative 2 times 1 gives us negative 2. Alright, minus 3. Simplify here, it gives us negative 1. Alright, minus 3. So our result is negative 4. So we know y, alright, y is going to be equal to negative 4. So that's our vertex. Okay, so our vertex is 1 and negative 4. Alright. So let me make a little graph. There we go. Alright, so it's negative 5. It's 1, 2, 3, 4, 5. Positive 5. Alright, so 1 and negative 4, that's our vertex. So 1, negative 4. So our vertex is right there. So I'm going to plot the vertex. Now, is this parabola going to be happy or sad? Alright, so if the a value is positive 1, we know the parabola will be happy. Alright, so what I'm doing is, for now, I'm just going to sketch, alright, a happy parabola. Okay, so just show me that you know that it should be happy. And now the axis of symmetry, remember, is a vertical line going straight down, right, the middle of the parabola. I don't know if this parabola doesn't look symmetrical, but just remember that it's symmetrical. So the axis of symmetry here, right? Now what you have to remember is the axis of symmetry is equal to the x value of the vertex, right? So the x value of the vertex was 1, so the axis of symmetry here is x is equal to 1. Or if you just think about it, right, isn't this a vertical line, right, that goes through 1 on the x-axis? So how did we write that equation before? It would be x is equal to 1. Okay, or just remember the axis of symmetry is equal to the x value of the vertex. Okay. Now, how do you find the minimum or maximum value, alright, of a quadratic? Alright, first of all, let's talk about when we have a maximum or a minimum. Okay, so let's say we have a happy parabola. Alright, if a parabola is happy, alright, the vertex is its lowest point, so we have a minimum. So now let's think, well, when is the parabola happy? The parabola is happy when a is positive, right? When a is positive, right, the parabola is happy. So you have to remember, alright, so when do we have a minimum? Alright, if a is positive, we're going to have a minimum. Now, if the parabola is sad, alright, the vertex is the highest point, so that's called a maximum. And when is the parabola sad? When a is, alright, negative. Okay, so if a is negative, we know we're going to have a maximum. Okay, and what you have to remember now is this right here. The maximum or minimum value of a quadratic is the y value of its vertex. Okay, is the y value of the vertex. Okay, now remember, you can only have a maximum or a minimum. You can't have both. Alright, a parabola can't have a highest point. Alright, the vertex can't be the highest and the lowest point. That doesn't make sense. So you can have a maximum or a minimum. Okay, so right here, if you have a question like this where it says find the minimum or maximum value, right? So in this case, it just asks us to find the minimum value. You have to know that, well, the minimum value is the y value of the vertex. So we need to find the vertex. Okay? And if we have a quadratic here in standard form, how do we find the vertex? Alright, to find the vertex, we have to know, alright, to find the x value of the vertex, we're going to use negative b over 2a. So to find the x value of the vertex, alright, we're going to use negative b over 2a. So that's, in this case, it's going to be negative, alright, 12 over 2 times 3. So that's going to give us negative 12 over 6. So x is going to be equal to negative 2. Right. So how do we find y again? We're going to take x and plug it in, alright, to the problem, and that'll give us y. Because y equals to, alright, basically this quadratic, and we're going to plug in x. So 3 times negative 2 squared plus 12 times negative 2 plus 8. Alright, let's simplify. Make sure you simplify the exponent here before you multiply. Alright, follow the order of operations. So this will give us 4 times 3, so that's 12. Alright, this will give us negative 24 plus 8. So 12 minus 24 is negative, alright, negative 12 plus 8. So our result is negative 4. Okay? So negative 4. Then now you have to remember, alright, the minimum value is equal to the y value of the vertex, right? So the y value of the vertex is negative 4, so the minimum is equal to negative 4. Okay?